Okay, so these variables now might also have exponents. So that's going to be like the biggest change from 5.1 to 5.2. So when we're referring to m and n in each of these stipulations, what we're actually referring to is the exponent in our numerator and the exponent in our denominator. Okay, so the way that you would read these is if m is less than n, then you automatically can just go say, okay, y equals 0, that's my horizontal asymptote. If these two exponents are equal, then you have to go through the process of taking the coefficients and setting them over top one another to then find your horizontal asymptote. And lastly, what if your numerator or your exponent in your numerator is bigger than your exponent in your denominator? There's not a horizontal asymptote at all. So before, our horizontal asymptote was kind of like our easiest thing to find. It was just the number out to the side, and that was all we had to do. Now it gets a little bit more complicated. We have these three stipulations. So what I would suggest is I have them written off to the side here. It's nice to keep them close by. So every time you turn a page, you might want to like write them up at the top really quick and like give yourself just like a little jotted note. You obviously have all the big ones written down and like the whole sentence written down, but what I would suggest doing is just making sure that you keep these written up at the top of the page for every time you flip a page. Okay. You're fine. Bye, Bash.
Cheyenne's waiting to get into the Zoom.
Yep, she just came in. Okay, so we're gonna go straight to an example. The example we're going to do is y equals x squared over x minus 2. So it looks a little bit different than Tuesday, right? Like we're stepping it up a notch. Yeah.
Just woke up, so I have to go take my dog out real quick.
Okay, just make sure you turn your camera on when you come back.
Okay.
Okay, so I want you to first try to do this on your own and try to determine what your horizontal asymptote is. Thinking back to these three stipulations, okay, so you have to go identify what your exponents are, remember. Okay, so I'm gonna tell you right now, m was your top and n was your denominator exponent. I just want you to try it. You might be like, I don't know what you think you're doing. I have no idea what it is, but just go ahead and try it.
My eyelids are so heavy.
Oh no, I'm sorry. Try to keep them awake, Quentin.
What? I'm trying.
All right, so m is the exponent in your numerator, right? So that is 2. And then what's the exponent to my denominator? Yeah, if there's nothing written there, it's technically 1. Okay, so let's compare 2 and 1. 2 is my numerator, 1 is my denominator. Is 2 or 1 larger?
2.
2. Okay, so that means we can put our little caret or like alligator sign, I don't know what you want to call it, going that way. What we're saying is that our numerator or our m is greater than our n or exponent in our denominator. So what does that mean over here? Do I have an asymptote or what is it if I do?
That is a yes, and that would be the n greater than n, and that
Right.
would be none.
Good. Okay, so if m is greater than n, you have no horizontal asymptote.
Oh,
So we're just
yeah,
gonna
you
put a
don't.
big no. Yeah, no, it's not happening. No horizontal asymptote, right? Because our m is larger than our n. Does that make sense? Okay, we're gonna practice it a lot more, I promise. Do you remember how you found your vertical asymptote on Tuesday? I know.
Yes.
It's a long ways away. Or it was a long time ago, it feels like. It was something to do with the denominator.
My mom doesn't agree with the Wednesday thing when my brother tries.
Yes, you said it equal to 0. So we take our denominator, which is x minus 2, and we set it equal to 0. What do I do to actually find that asymptote then?
Use plus add 2.
Yeah, we have to solve for x, so we add 2. So x equals positive 2.
Yeah.
Do we know how to go graph these on our graph?
See, now once you put like a bunch of exponents and stuff in
I
there,
think we do.
that's when it's gonna be a pain in the butt.
They won't get any bigger than this, really, honestly.
You're joking.
No, they really won't. Not too much. We might say like x squared plus x. That's gonna be the biggest that they're gonna get. No, that's really the biggest they'll get.
See, it's easy now, but then when it comes to the tests, my brain is just like out of gas.
Make a note card. Then when you're out of gas, you can look to your note card.
Can I just like rip
So if
off this
we-
part?
Have no horizontal asymptote. We don't have to draw them, right? We're good. For vertical asymptote, we have to draw that at x equals 2. So we have our dashed line. Remember, asymptotes are dashed lines. So we only have one asymptote here. Yeah, question.
So what does it like mean if there's no asymptote?
Good. What it's saying is that there's not a single point horizontally that our function is discontinued. So for example, when
Like
she,
it could go all over like the graph like up and down.
yes, it's only this one part where it's discontinued. And actually, she brings up a really great question, like what is an asymptote and like what does it mean to our function? So let me ask you, the significance of this 2 is that what if you put a 2 in for your x in your denominator? What would your denominator equal? 0. Can you have a denominator that equals 0? No, that's where a function's undefined. So basically asymptotes represent portions or in like absolute straight lines of our function that are totally undefined. So what we're saying is that there's no portion along any horizontal lines in our function that are undefined. That's a great question. Okay, now we have to get to the graphing portion of it. That's when we pop open the XY table, right? So this was everyone's like trickiest thing, I think, was doing the XY table. Do you remember, how do I choose my points? Yeah, 3 to the left, 3 to the right. Specifically of what? Yeah, vertical asymptote. So I choose 3 points to the left, which is 1, 0, and -1, or -1, 0, 1. And then 3 points to the right, which is 3, 4, and 5. Okay, but now, how do I find the corresponding y values? For instance, like, I want to specifically right now test
It
my
would be
-1.
+1
How'd you find that?
because it's on the other side of the graph. Oh no, wait a minute.
Right, so how, if I have an x value, how do I find its corresponding y value?
By like making it go.
Yeah, you plug it in. Okay, plug it into what? The x in my original function. Okay, so let me show you that first one again, then I'll let you go ahead and find the rest of these on your own. The hard part is I have multiple variables now. So I have y equals x squared. I'm putting in -1 for x. So it will be -1 squared. I also have to put x or -1 in for my x in my denominator. So -1 minus 2. There's nothing on the outside of this function, only in here. Okay, so what I would suggest is just making sure that you have parentheses around your denominator if you put this into a calculator.
How come that goes 1, 3, 4, 5?
Yeah.
Okay,
Good.
1, 2, 3, 4, 5.
Could we have an x value at 2?
Oh no.
No, because the asymptote is there. All right, go find these y values.
We have a question.
Yeah.
So you know the asymptote is there and you can never reach it, so go as close to it as you can.
So you will have points that are 1.9999999 repeating. Or you could have the point 2.000000001, but you could never have the point 2. Does that make sense? Yes, it becomes positive. Good.
even if it can never reach it, but it's still getting closer.
Yeah. Cause you can just add on a 9, and now you're closer, add on a 9, and now you're closer.
And that's like a paragraph.
Do I have to distance between me and the wall?
It's a close paragraph.
So if I have to distance between my hand and your face,
I've never actually reached it.
I've never actually.
I know, I understand that,
So
but
we
is
can
that
have
like
the
a
point
paragraph?
-1, -1. So -1
Pretty sure.
Like, you like this?
Oh, okay, so you have to put on your actual XY table. Okay,
I get it now. Thank you.
All right, make sure you're finding the Y values. We're gonna go over them really quick.
Wait, what?
This was everyone's like biggest confusion, I think I'd say.
Am I stupid?
No,
Then why did I get -5 for the first one? I did that, but then I just like added those. So this is -1 here.
Good, okay,
Oh, and then it would be 2, and then it would be 1. So then it would be -1.
What's
Oh,
-1?
+1.
Minus. What's -1 minus 2?
-1 minus 2 is -1.
-3.
Wait,
So
-1 minus 2? Oh, yeah, -3.
Right, I'm already at -1, so 2 more negatives.
Okay, yep, -3.
Yeah, it's got -1 there. What if there's a 0 if it's not already?
Good, okay. So what's 0 squared?
0.
Good, okay. So now what's 0 minus 2?
-2.
Good, 0 divided by 2, or -2 is just 0. But it's defined because there's no 0.
That's right.
So you can do it that way. So it is real, it's good. So you can put a 0 there.
Oh, okay, thank you.
Yep.
I think I did.
Elijah.
Oh, negative one.
You're like the only teacher who has a problem with that.
Yeah.
Everybody else is just like, keep back.
Why do you think it's negative one?
What are you doing?
Oh, this right here?
How dare you.
Oh, actually.
Okay, I did see it.
I remember what I wanted to do.
Elijah.
I did my head.
You can film me doing it. That works.
No one's gonna know I.
Jonathan?
Johnny!
What?
Anthony Quinton and Elijah.
Me too.
Can't see my facial expression.
It's like barely under the line.
Oh,
All right, does anyone have 1, 3, 4, 5?
What's 0 from 0?
For 1, I got -2.
Okay, and then 3, 4, 5?
3, I got 9, but that might be wrong.
And then I got 8.
Okay,
You said you have.
And then 8.3.
okay, something's going on. Oh, no, that's good, that's good. Yeah. Oh, no, we're good. Okay.
Wait, so this is what I'm doing, right?
I'm honestly
Okay.
with it.
Okay,
I wouldn't even remember.
so what you should have gotten for these is up on the board. Okay, so the biggest thing here is making sure when you put in a negative in your calculator and you're trying to square it, make sure you put parentheses around it because we know a negative times a negative makes a positive. But for some reason, when you put something in your calculator and you know it's wrong, you just still believe it because it's your calculator. But if you did not put parentheses in your calculator, you would not have gotten the correct answer. And then making sure we know when you have a negative and you subtract a number, you go more negative. Okay, so you should have gotten all of these y values. So let's try to graph these now. We have -1, -1/3, 0, 0, and 1, -1. Okay, So we're just gonna follow that pattern. So if I'm going from here, that means I'm coming up and I take a sharp turn down. And I have that path. Even though there's no horizontal asymptote here, you're still just gonna follow those points. So this is what the points are kind of taking you
Wait,
to,
I'm confused. Where's the negative one term? Where is that?
right here.
Nice job.
Okay. So when I grab this, I go up the zero, right?
Yep, up to 0 and then back down to 1, -1.
No, but I'm grabbing it based on like the regular thing. There's nothing, when I'm putting the dots, there's nothing to do with that, like, other than.
Nope, just graph them regular.
Okay.
Yep. And then 3, guys, stop. 3, see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 3, 9, 4, 8, and 5, 8.3, so up just a tiny bit more. So notice the shape of those dots, like you're coming, it's telling you to go still in a curve. So we're still gonna come up from this direction and then follow along that asymptote. So notice it kind of still looks the same as stuff that we did on Tuesday, but there's no horizontal asymptote bringing us a little bit closer. Yeah. Yep. You can, yes, you can if you want to, absolutely. All right, domain and range. Let's do the first one together.
I can't make it anymore.
Let's do the first one together here. I don't want to do range on this one. I only want to make you do domain. I'm gonna confuse you if I make you do range on this one, so I only want to make you do domain. What is domain? Is it up and down or left and right? Good. Horizontal. So here's the tricky part. Because we're going horizontally and we're working from left to right, we actually have to focus on our vertical asymptote, which kind of seems confusing. But if we're working left to right, what we're gonna hit is this horizontal or vertical asymptote. So if I'm starting here, can I go all the way left, or is anything gonna stop me? No, and way, way, way over here is called negative infinity, right? As I'm coming from way over from negative infinity and I'm working my way to the right, I'm gonna hit this asymptote. Can you have a point on an asymptote?
No.
No, so I have to put that value down. 2 is where I'm not defined, so I can't have points there. So we go from, yeah,
So why wouldn't you put like 1.9 repeating since you can't
good.
go on?
Good, because we can get as absolutely close to 2 as possible. You could have 1.9999999, but you just can't go over the edge to 2. So 1.9 is real, but 2 is not. So you say you can have points all the way from negative infinity, but not at 2. So,
So when you put down like a number
Yeah.
on there next to your infinity sign,
yeah,
that doesn't mean that it's going to that point.
Yes.
Like it's not like touching that point.
Yes.
It's just going,
absolutely as close.
because like when I think like coordinates, I think it's
Yeah.
going to this specific like.
Yeah, yeah. And so once you get deeper into some of these graphs, we're gonna start having things where we say you can include this point, and if you can include, you use a bracket. So since we're not including, we use parentheses. That's a great question too. Am I finished or do I have more? More, right? I'm gonna start back up at 2 and I say, well, 2 is where I left off. After 2, I can start back up again. And I'm gonna go to positive infinity. And again, I'm not gonna have you do range on this one, so I don't think I want to confuse you. All right, questions? Questions at all?
If we were doing range, do we do it the same way?
Yes.
For horizontal?
Yep, just up and down, yep, and we'll do it on the next one too. I don't wanna confuse you with this one because there's not one, so I don't wanna
This
miss that. It does take a while.
7.
Okay, how much time do we have left? We have time for you guys to try one. All right, we're gonna let you guys try one on your own. I'll kind of take you through it step by step. Can we all agree these take forever? Yeah.
That wasn't that long.
Okay.
Can I take a little walk
Where?
to like the water fountain?
And back. Okay. We are going to try. Yeah, I like this one. Y equals 2x squared minus 9. The first two huge things I want you to do for me is to find your vertical asymptote and your horizontal asymptote. Those are the first two huge things I want you to try here. So again, think about horizontal asymptote, look at your exponents, and then decide what they mean for our three stipulations. Okay, and vertical asymptote, set your denominator equal to 0 and solve. I don't want you to go further than that though. This will be like the trickiest I can get for you. Set equal to denominator. Set equal to 0 and solve for x. Denominator.
It's the best one, where I want my
Denominator is your bottom.
where I was sleeping. That's like
Yeah.
the top.
That's your
So
bottom.
what do you do with it?
No, I said denominator. Denominator is.
Yeah, I can't
You
go to
have
sleep.
it right here. Set equal to 0. We want to take this and say x squared minus 9.
It's over.
Then it goes read it out.
I don't get how to find
Okay, so what's your?
My main content on Benji.
What is your exponent? Okay, so what happens if you're open? Okay, good. Good, so what's, you wrote your coefficients. So what's the outcome of this one? 2 over, good. Okay, get as far as you can, take like 30 more seconds. Okay, so vertical asymptote. Vertical asymptote, how do we find that? Guys, how do we find vertical asymptote? There we go. So we have x squared minus 9 equal to 0, and I have to solve for x, right? All right. So we add 9 to get x squared equals 9. How do I get rid of a square? Square root. What is, and here's the part that I wanted you to make a mistake on so you would never forget it. What's a symbol I have to add on if I take the square root of something? Yes, positive or negative, or plus or minus. So we're saying x equals plus or minus. Why do I have to take that? What is the square root of 9? Couldn't it have been a negative times negative 3 to make a positive 9? Yeah. So we have to say positive and negative 3. We'll get to that in a second, how that gets graphed. We have to do 2, which will make this confusing. I promise we'll do lots of practice over this tomorrow. Like, I'm not gonna ditch you on this. We're gonna take lots of time to practice it.
I found a way to wake myself up.
All right, horizontal asymptote. So tell me something about the exponents. What's my numerator exponent? Yes, okay. My exponents are the same. If my exponents are equal, you have to take A over C. But what does that mean to me? Like, what's my A, what's my C?
2 and 1.
Good, because we take the coefficients or numbers out in front of our variables and put them over top one another.
Is your brother on there yet?
So we have a 2 in our numerator, right? That's the number directly in front of my x. Since there's no number, it's a 1. So we're gonna have a y equals 2 horizontal asymptote. Okay, I'm gonna help you set these up on your graph. Okay, so let's just tackle the one that we all are wondering about first, the vertical asymptote. How do I do a positive negative 3? Like, how do I show on my graph plus or minus 3? You have to do both versions. Okay, so we have to graph the asymptote for positive 3, which would be over here.
So the vertical one is gonna be goes over the one.
Yes.
Yes, that is okay.
So then our negative 3 as well has to have its asymptote graphed.
So are we gonna be ones like in between them?
Yes. Okay, so now we can go to horizontal. It's at positive 2. So this looks kind of looks like a little tic-tac-toe game, but it looks a little bit different than what you're used to, right?
Okay, so I have a question.
Yeah.
So we have all these different almost like boundaries.
Yes.
Does it mean that it, like, no matter what curve thing you're making, that it can't touch any of them, or it just can't touch the one that it's like?
That's a great question. We can't touch any of them. So say we have a function in this corner, it has to be contained right here. And then we might have one in the middle, it's gotta be contained in the middle. And then one over here has to be contained over there. So no asymptote can ever be touched or crossed.
Will it be like, will there still be opposites or
And
where they are?
good question. With this one, it starts to get a little bit weird. I'm gonna show you what kind of possibilities can happen here. You can end up having,
So you can make like a lot of numbers in the XY table.
you do, and I'll let you choose 2 on each side instead. You could have something here and here and here. The possibilities when you have multiple vertical asymptotes start to kind of be a little bit endless. They don't necessarily
Norman,
kitty corner. Yeah.
I can't see anything.
All I'm doing is this right here. So they can take a little bit different shape. And this is the one where there's no guaranteed shape that you'll have. Okay? So what we're gonna do tomorrow is kind of pick this back up where we're leaving off. And we're only have what left? The XY table. Okay, that's the only thing we have to still do here is that XY table. No homework, you're good. If you want to try to finish that XY table, please feel free to. All right, go ahead.